And last point, nature of living group. So the last thing we want to look at the living group ability. So we have alkyl halide, maybe alcohol and ether also. These are the living group. Any upcoming nucleophile comes and R and U is formed as a product, and X minus, OH minus and OR minus is a leaving group. So if leaving group leave faster, if leaving group leave faster, rate of SN reaction, either SN1 or 2, reaction will be higher. If leaving group leave faster, rate will be higher in both the SN1 or SN2 reaction. So weaker base is always better leaving group. Weaker base is always better leaving group. So if we look at the data, F minus, Cl minus, Br minus and I minus, CX bond energy and pKa of HX. If we look at the data, fluoride ion has 118 kilocalorie. Chloride ion is 81 kilocalorie. 67 kilocalorie bromide ion, and for iodide 54 kilocalorie. And if we look at the pKa value of HF, +3, -7, -9 and -10. So pKa value is negative, most negative. So Hi is a strong acid. If Hi is strong acid, so 54, here is a 54 kilocalorie. So I minus is weak base. Weak base. So weak base is always better leaving group. Weak base is always better leaving group. So leaving group ability, if we're talking about leaving group ability and rate of SN reaction, Ri is faster than RBr, RCl and RF, because I minus is good leaving group. Good leaving group, because weaker base, because weaker base, because weaker base is always better leaving group. Always remember this slogan, weaker base is always better leaving group. So I minus, we can see the data. I minus is weak base. So good leaving group. And fluoride ion is poor leaving group. So always remember this is the rate of SN reaction, either SN1 or SN2. So we can also say leaving group ability is directly proportional to acidic strength of conjugate acid. Either you can remember weaker base is always better leaving group. So this is the factor behind SN reaction. Thank you.